All set. Okay. Good afternoon. Welcome. My name is Kevin Krejci. I've got a little script they prepared for me here. I'm the afternoon MC of the upstairs Yahoo Lounge. I'm the Business Development Alliance Manager at Fujitsu Laboratories and the paparazzi today, carrying around my big telephoto lens. But enough about me. What I'd like to do is introduce this esteemed panel we've got here, and I'll just hand it over to the moderator first of all. Just to be clear, you're in the panel SDN and Next Generation Communication Infrastructure for End-to-End Connectivity in the IoT Era. Okay. Whoa. Did you catch all that? Okay, and so first I'd like to introduce Min Hee. He's an SDN architect and distinguished engineer at Fujitsu Network Communications. And he will go ahead and introduce the panelists and take it from here. Have a great panel. Okay. Thank you, Min.
Yeah, thank you, Kevin. So I walk this way.
I'll go put this back.
Thank you very much. Thank you for coming here this afternoon. So today with this panel, we're talking about connectivities. So let's get started. Is it on? Okay. Internet of Things. Internet of Things is a whole bunch of devices, billions of devices connect together around the globe. So what is the challenge of the Internet of Things? Sensor, we know that sensor is very important. So that's the interface between the physical world and the digital world. So sensor is very important. Security is even more important. So security guarantee we have the Internet of the Thing do a good thing for us rather than bad thing. So for this one, actually, I was reading some articles in Newsweek. They're talking about like Bill Gates, Elon Musk, and Steve Hawkins talking about how scary is artificial intelligence is. They say artificial intelligence maybe has a threat to our own existence. So I was thinking, wow, that could be the truth. But artificial intelligence plus IoT, so those devices talk to each other, bypass human, that's even more scary. So it is. We do not know the world is going to be looks like in the future, but IoT definitely is a part of a big story of that. Power. So power assumptions are important. I read somewhere they said in 2013 there are $80 billion wasted on those online devices, which like our set-top box and all those things, just connect to the power but not do anything and waiting time. There's 80 billion. That's an amazing number. But obviously, this how do you handle the power? And that's a big item. Programmabilities. So how can you make different vendors' device work together? How do you make it easy to program? And how to standardize the interface is also a big challenge. Cloud, obviously, is our brain. And connectivities. So today, our panel, the discussion topic is about connectivities. Mostly is connectivities. Connectivity is very important. So knowing your connectivity is important. Look at this. This guy is not enough connectivities, okay? But this guy, too much connectivities, okay? So, it's so much, and then you want to find a way is how can I hack into this smart device to disconnect them so it doesn't, control me rather than I control the device. But that could be a problem down the road in the future in our smart device. If they are too smart or something wrong, and I don't know what will happen. But so that means the connectivity and the security not only about other people, about the human breaching the security, about the machine as well. So good thing today we have all those distinguished panelists talk about the connectivity. They will help us out. So the topic of today's discussion is a long one. Okay, SDN and next generation of a communication infrastructure for end-to-end connectivity in the IoT era. It's a long one. So basically, we're going to examine the impact of IoT on communication infrastructure And then we'll see how SDN and NFV may offer some of the solution, may not be all of the solution, but they may offer some of the solution. And also we envision 5 years from now, 2020, and how's the network going to look like, the network landscape looks like. So today we have our panelists offer their perspective and insight on all those topics. So let me quickly introduce our panelists. First I have Professor Guru Paraka. So he's a Stanford professor and also the founder and executive director of Open Network Research Center. So he's going to give us a talk. And next one is Mr. Motoyoshi Sakiasan. So he's a director in Fujitsu Lab America. And Mr. Bob Lieber is a director from British Telecom. So our panelist is going to discuss those topics. So the way it works is we're going to have the panelists come up, give a presentation, 10-minute presentation, and then please hold all your question until the Q&A session. So, and then this session we have 15 minutes. After 15 minutes, when this session is concluded, if you have additional questions, our panelists will stay around here for additional 15, 20 minutes, and then you could reach out to him and ask additional question to him. Okay? So now let's get started. Our first speaker is going to be Bob Lieber. Bob.
Thank you, Ben. And welcome. Thank you all as well for taking the time out of your day to join this particular session. While Min gets paid per title, right, and that's why that big long title, I'm getting paid per slide. So I'm going to take my time and run you through every single slide I have. Only kidding, of course. Again, my name is Bob Lieber. I'm with BT. Some of you know it as British Telecom. And I'm here to talk about this SDN and IoT. So the first thing is, has anybody deployed SDN? Good. It's a very green audience. Guru, you're not invited to answer these questions. Also, it's a very tough name to argue against, right? I'm Bob, he's Guru. Well, so we have all of these devices out on the internet now already. How many are there? Millions, if not billions, okay? That number is not decreasing. That number is increasing significantly. And the number of those devices and the things that they're doing with these devices. Traffic lights, window shades, pet tracking devices. They even have an interconnected helmet for those riding motorcycles. It's incredible for someone like me who was absolutely blown away years ago when I worked for a small company called RCA, Radio Corporation of America, and I was granted access to the fax machine. I thought I hit it big. Now, every time you turn around, something is connected. Now, what's happening with all these devices? Just like our cell phones during a sporting event or some other activity, New Year's, whatever the case may be, everything comes together and almost forms a bottleneck on the network, right? Things get really tight, and that's what we're seeing here. We have the IoT, everything coming together, all of these devices coming together and converging on the network. And you can see it's all coming down into this SDN network and creating that bottleneck. Some say 50 billion by 2020. Some say 30 billion. Some say 40 billion. I'm sure if you had some money, you could go to Las Vegas, put your money on $42.5 billion. Maybe you'll win. Okay, so how then, some people say, well, so does SDN even equate to IoT? Well, I believe it does. And I think there's reasons and rationale behind that because, again, you have to balance these technologies to an extent because you're having all of the devices converging together, and what are you going to do with them actually on the network? They're connected, they're interconnected, and you have to make sure that you weigh that balance between them. While SDN, of course you know what it stands for, right? Software-defined networks. I'm not here to change that name, but I'd like to, because I don't think it's just software-defined network. It's a smarter or a smart network as well, right? So the networks themselves are becoming more intelligent. Why? Because human beings are coming into play and making them smarter. How are we doing that? Software-defined networks. Okay? So these smarter networks are making the most of some of the depleted resources on the network. You have some equipment that's idle, some equipment that isn't fully utilized, and it's the intelligence behind the SDN that is making these resources a lot more available and a lot more efficient within the network. Okay? There's a few things that I think you need to take a look at within the SDN. You have the service chaining, which will sequence the applications to make sure that they're running as efficiently as possible. The bandwidth calendaring, that's going to help you with your quality of service, right? Because if you're passing data versus voice, you want to have a different quality of service, so you need to keep those components, those aspects in mind when you build that. And one of my favorites is the dynamic load, okay? Making sure that on the fly, again, these smart SDN networks have the ability to manipulate the bandwidth and decide who is going to get the most and when they're going to get it as well. Okay? And shameless plug also, because I'm a huge IP address management guru. Don't forget the underlying technologies as well. All of these devices are going to have IP addresses, whether it's IPv4, IPv6. They're going to have to get that address somehow, typically from a DHCP server. Again, whether it's v4 or v6, doesn't matter. And then the same thing with the DNS service, to make sure that you can pass those DNS names and do those reverse lookups without issue. So just the basic architecture, okay, not in real detail. Really, three basic layers, if you will. You have your application layer, coming from the controller, and then you have your existing infrastructure, right? This physical network here, which is your existing infrastructure, then needs to talk to the controller. This is the smart guys and gal. Then that gets pushed up into these Internet of Things, into these Internet devices, okay? One of the problems that at least I see, well, I shouldn't even say problem, more of a challenge, if you will, and that is making sure the controller is secure. I see that potentially as a single point of failure and also with security concerns. Let's just maybe use an example, and let's use a home network maybe. If somebody's able to hack into your connected icebox or dryer or washer or whatever device you have at home, they also could probably then hack into your garage door opener, which, by the way, is also on the same network and having an IP address. And now they can gain access to your house. So some people say, well, I'm covering all my data. I'm covering all my information. Well, yeah, don't forget about the physical threat as well of somebody actually gaining access through the home security system, through your garage door opener, whatever the case may be, and gaining access into your home. And the same thing works with a business. If a business has all of these internet devices, the Internet of Things, same thing could happen. You could gain access through the security system. And just by writing a script, I'm not going to tell you how to hack, but getting into the system and then manipulating and becoming one of the actual devices in that network. So OpenFlow is one of the controllers. It basically enables SDN, and it sits on top of TCP, and it's very much like TCP. It's a protocol that is utilized for this specific reason, for SDN. What are the considerations? Okay, I think first and foremost, not that I would steer anybody one direction or another. When I managed networks, global networks, I like to focus on open source. I like to focus more on the open technologies. Not that there's a right way or a wrong way going into open source or open versus a vendor-specific technology, but it's just a consideration, something to think about when you start to dream how you're going to manage your SDN network, how you're going to build that SDN network, and how you're going to manage all of those devices or the IoTs. Understanding the technology itself is very critical. And then at the same time, I say understand the SDN technologies, speak with other organizations or corporations that have struggled through it. What a concept. Somebody already tripped and fell. Maybe there's a different way. Maybe there's a different path. So a lot of organizations, a lot of corporations are doing it today. Speak with them, get a better understanding of what pitfalls they ran into and how they avoided them. I'm really big on QoS, as you could imagine, right? This quality of service, I want to make sure that the devices that need that higher bandwidth, that need that higher quality of service, maintain it throughout their entire connectivity. And I think there's a lot of pilot programs that you could run. Use a small portion of your network. Start slow and gradually work your way up. One of the things also that folks are finding, equipment that is about 3.5, sometimes 4 years old, is not ready for SDN. It just doesn't have the wherewithal, or it doesn't have the technology built into it to support the SDN network. So it's another, again, consideration. Make sure that your network equipment today does support it. And last but not least, do a due diligence on your entire network. Look at everything, look at the concepts, look at everything that's going on, and don't be afraid to engage a professional services team. Make sure that you have somebody looking at your network from the outside in instead of you from the inside in, because they're going to give you a much better perspective. Okay? Sometimes these professional service engagements are worth their weight in gold. So, we're not just connected, we're interconnected. And that's the point. Look after the security of everything. Make sure that the connectivity from one device can't be hacked into another. Make sure you have everything locked down, locked solid. And again, from an IP address management standpoint, make sure that you have the right tools in place. So if we're exploding to millions of IP addresses, I'm not sure how big all of your businesses are, but they're going to expand, they're going to grow. Make sure that you have not an Excel spreadsheet, but a commercial off-the-shelf tool that is going to manage all of this IP address space, that can communicate with your DHCP service, that can communicate with your DNS service, and make everything interconnected as one. At BT, we have a small saying that's why the first slide and my last slide talk about the art of connecting. We're looking at connectivity and connections at not just the science anymore. It's more of an art form as well. And so that's why we introduce and or run this particular theme of the art of connecting. That's all I have for you. Thank you very much. I'm not sure if you're clapping because I'm finished or you're clapping because you like what you heard. But either way, I appreciate it.
Thank you, Bob. So our next speaker is Motoyoshi Sakiasan. So Sakiasan leading the research group in photonics, network, optical transmission system, and SDN. So he also served as many technical committee members of many standard and industry organizations. Meanwhile, he's also an inventor. He has more than 70 patents. 70. That's impressive. Okay.
Thank you for the introduction. My name is Motoyoshi Sekiya, Fujitsu Laboratory maker. Long title, I'll skip. So initially, there is so many emerging technology. One is SDN and NFV, and big data, cloud computing, and today's focus, IoT. 7 trillion trillion market in 5 years, and in 5 years, 50 billion, I think 50 or 30 billion connected, everything. That's IoT. Kitchen, it's connected. I don't know it's true or not. But what's the network requirement? These are key topics. Scalable, it's a truly scalable, 50 billion. And ubiquitous, mobile, car is very fast mobile. And heterogeneous, kitchen, work with dog, something. And dynamicity. These are the network requirements. By the way, how is the traffic? Global MCM connection will be the 26% growth. This connection is 84% growth of the traffic. And wearable device, it's 52%. This generation, more 100% growth. How to deal with such traffic? It's a core network challenge. So that core network to be the cloud with the cloud processing analytics, that's a challenge of the IoT era. So what impact to core networks? One is tremendous data volume. It requires a capacity requirement. For example, the optical transmission point of view, this kind of the growth, 5 years, 10 times traffic. We have to continue this growth. And another requirement is the variety. So many different type of the sensor, curve, camera, these are different requirements. So we have to handle how to manage this variety of requirements. It is a heterogeneous and dynamic challenge. And most important is the number of data sources, 50 billion connected. Is it possible? Too much complexity. Even the complex, we have to guarantee the reliability, and some intelligence have to solve it. So what's the keyword to realize that? That's the virtualization. So currently, especially for the photonics network, it's a static, manual, but now automatic or dynamic. After that, important thing is that to virtualize that. By virtualize, connect over the heterogeneous layer protocol or vendor independent. And by virtualizing, provide good usabilities. Complexity is hidden. And reliability also realized in virtual layer. So connecting into end will be enabled by SDN. That's the meaning of the virtualization. For the core network, one of the areas, the optical network, that will be virtualized in the IoT era. Large capacity with low latency and programmable. That network will be provided by the virtual optical network. virtual optical network on top of the physical flexible dynamic network, and application access to the virtual. So virtual layer is the key to realize such dynamicity and scale and heterogeneous. So how is, well, SDN cover the end-to-end? Until 2013, SDN already show data center network is very, very suitable and benefit inside the data center. Now expand SDN to the wide area network in the core or metro. This is a challenge is ongoing. Next will be the mobile or center network. If SDN success to manage there, SDN will enable to connect everything from the device to application. That is the next 5-year challenge for the IoT era. So finally, what's the future network? Application service is using the virtual network. And under the virtual network, everything wireless, core network, and IoT is managed independently. That's my view. Thank you for taking time.
Thank you, thank you, Sakiasan. So next speaker is Professor Guru Paraka. So Guru is the professor in Stanford University and also the founder and the executive director of Open Network Resource Center. And before that, he also worked as a professor in Washington University in St. Louis. And before that, he has a lot of industry experience and several startups and Cisco. So he will bring a lot of insight. Thank you.
Thank you. Appreciate it. Thanks for your participation and coming to this particular session. So I guess when I saw Min's title, that long title, it has two things, SDN and IoT. Okay. I think I should step back. So there were two big things, SDN and IoT. So I thought the real question that Min is trying to pose is there a synergy between SDN and IoT? So I will try to answer that particular question in whatever next 10 minutes. So I think, and why do we put these things together? Because, both of them are mega trends. These are big trends that are happening. And so the temptation is when you put one mega trend with another mega trend, do you think there is a mega trend? That's what we are trying to talk about and get you all excited and so on. But I think when you put them together, especially in whatever 2015, maybe they are coming together, maybe it is too early. And that is kind of the thing I want to build on. So let me start with SDN. That is something I'm quite familiar with. IoT I'm not as familiar with, but let me start with software-defined networking. So what is software-defined networking's the core value proposition, in case you haven't heard this before? So the thing is, today we build our network infrastructure using what we call routers, switches, and middle boxes. If you look at these boxes, they are very vertically integrated, closed and proprietary boxes. And that is how we build our network infrastructure. And to some extent, there is nothing wrong with that. This is kind of how the industry has evolved in the last 20, 30 years. But if you are a network operator, what happens is, if you build a network like this, you don't have much flexibility or you don't have much control over your own network because you're working with closed proprietary boxes. They don't have the programmability. So what SDN tried to do is to take this control plane right now that is embedded in the boxes and take this control plane out of the boxes. And then that control plane can run in software on servers. And not only that, another important concept is that once you have this network operating system, that is the kind of the control plane, what it does for you is it creates this network map at a logically centralized place. So you may be running a large network that may have thousands of devices, but this network operating system brings that entire network map at one place in memory or in a data structure you can think of. And once you have this network on your fingertips, then you can write these applications, either routing, traffic engineering, mobility management, or anything you can think of. very, very easily, because this is a network map. You write a simple application that is manipulating this network map. This is relatively straightforward to do and anybody can do. Bob talked about calling SDN smart networking. The reason it becomes smart is once you have this network map, then you can write this smarter and smarter application quite easily. And that is kind of the appeal of software-defined networking. There are a couple of other benefits to this, that of course it brings that openness that enables more innovation. It accelerates revenue generating services. If you can write those applications faster and faster and you are a network operator, you can bring more and more value to your end customers. And it also helps reduce your OPEX and CAPEX as well, because you don't have those big boxes, you can have the boxes similar. So that is kind of the appeal of SDN. Now another way to think about it is that right now we build these boxes like networks using boxes like this. In the future there may be boxes like this that are with merchant silicon, some switch operating system and agent, a network operating system and this. So this is how the deaggregation could work. Okay. Now as Bob asked you, has anybody deployed SDN, and there was hardly anybody who said yes. The reason being SDN is still quite new, right? I mean, there are deployments of SDN in data centers and some parts of the networks, but it's still quite new. And there is a lot of work that is going on in SDN. It is one of the most active areas of research and development. And if you look at the list, all the way from building blocks, software-defined silicon, to forwarding devices, to switch operating system, network operating system, all of that. Then there are use cases in various domains of use, data center, enterprise, service providers for packet and optical. And then there are a number of trials and deployments that are going on. So the point I'm trying to make is SDN is not still ready for prime time. We are trying very hard to make it ready for the prime time, but it is not yet there in some sense. In our own work at Open Networking Lab at Stanford, we are trying to build open source network operating system that Fujitsu is part of. Min is a very active participant in that, so that we can build a very distributed, scalable network operating system. So Bob also talked about that being a single point of failure. So what we are trying to build is a very scalable network operating system so that it can deal with very large networks, and it is built using multiple servers. So if one were to fail, the workload can be distributed to other servers and it continues to work. Okay. And then it has very high performance and things like that. Okay. Another thing we are trying to do again with this, with Fujitsu and AT&T and other partners, is to create use cases across the service provider networks. So if you talk to AT&T, they will say in the future they would like to think about entire network using these kinds of tiers. So the lowest tier is the access. It may be wired as well as wireless cellular. Then you have central offices. They want to model the central office like a data center, and inside the data center there are networking and SDN, then regional networks, then the POPs, and then backbone. And so we are trying to build use cases for each one of these tiers with ONRC as the network operating system and so on. So this is a work that is going on very actively, but we still have long ways to go before it is ready, kind of prime time. Okay, so now the idea is SDN good for Internet of Things? And so I think yes, because this idea of building this Internet of Things, separating the forwarding from the control and centralizing the control and giving you all that exposure to the entire network, this concept is extremely relevant to Internet of Things as well. And hopefully when we build Internet of Things networks, we will apply that approach as well. But, So I think but the thing is, when you think about Internet of Things, there are many, many other high priority problems that need to be solved before we will worry about how Internet of Things and SDN come together. So that is what I'm trying to communicate. So for example, what I wanted to quickly go over, and I'm not a part of this center, but this is something, you can call it a sister center that just got started at Stanford. It is led by Phil Lewis. He is a faculty member in the computer science and electrical engineering. And they started this new program called Secure Internet of Things project. Okay. And again, I'm not an expert, I'm not part of it, but point I'm trying to make is that there are almost 15 professors from 3 universities that are trying to say, how do we build Internet of Things? It has become a big buzzword, it has become a big trend, But we have long ways to go before we understand how to do Internet of Things and do it right. So let me tell you one particular very high-level architecture that this group has proposed as an architecture for Internet of Things, where the idea is that here are the things that we all talk about, all different kinds of things that you can imagine, right? Now, what is appealing about Internet of Things is these devices are connected through wireless, and very, very different types of wireless, not necessarily Wi-Fi, but Bluetooth and all different types of wireless things that you can connect very simple devices on. I mean, Bob talked about so many small devices. You can't afford to put a Wi-Fi interface on that because you don't have power, you don't have that, right? So then there is all of these different types of wireless interfaces or wireless protocols. They are very low power, sometimes battery operated and so on. And then through that, they connect to some gateway devices. They may connect to something like a smartphone, or they may connect to some kind of a handheld device, iPad or something. And that is how these devices will connect to the internet or the network. Once they are connected to that gateway device, then the life is very similar to how you have today through either 3G, 4G or TCP/IP, whatever you choose. And then you push all that data into the cloud. On the cloud, you do whatever your smart computing you need to do. And then you may run that application from here, and then you can kind of control those Internet of Things if you want to. Now the question is, when you look at that architecture, oh, by the way, before I go into that, here is a research agenda that they have described. And one aspect of that is security. And the security is, can you do all the operations in the encrypted mode? So imagine that the packet or data leaves the thing, whatever we call Internet of Things, and it is encrypted. The best way to get security is at the point of origination. If you can encrypt your data, let it go into the cloud, you do all your work using encrypted data, and then only when it comes to the final device, you decrypt it. That will be the most privacy secured way of doing it. And so what people at Stanford and other universities are trying to do is, how much can we do with encrypted data? But and there are some good algebra that is coming out that is saying you can do a lot, but it is maybe 1,000 times or 10,000 times slower, because you have to do a lot more complicated operations when you are doing with the encrypted data. So now if you slow down all of this computation by 1,000 times or 10,000 times, then how do you make it interactive? How do you make it still low latency? So there are some very interesting challenges that are there. And then the second part of it is, how do we build all the software infrastructure and applications so that we can do interesting things with all that data that is coming in? So the point, again, I'm trying to make is, unless we are able to solve these two big problems, right, that require 15 professors and more, it is kind of difficult to imagine Internet of Things becoming practical and ready for prime time. Okay, so my last thing, still the question is, how does SDN apply to Internet of Things? If I go back to this high-level architecture, clearly this part is more or less traditional networking. I mean, traditional in the sense of, once you go to the gateway on, then it is thing. And we know SDN applies here, because we are applying SDN in all of this, in reinventing and transforming the network. The next question is, does SDN apply on this particular link as well? So I think most likely the basic ideas do apply. Separation of control and data, simplifying forwarding devices, all those principles apply. But before you can apply those principles, you have to really solve the problems of this wireless stuff and how to make this work, how do you secure and all of that. Okay? So my takeaways are, SDN and IoT are two big and important trends. There is no doubt about that. I think we all agree. They are synergistic. IoT should be software defined. I mean, that is a good idea. That makes a lot of sense. IoT can be one of the growth opportunities for SDN, but both are in early stages of development. They will take their own adoption cycle. As every disruptive technology goes through an adoption cycle, they will go through the same thing. And coupling them together right now may be a bit premature, but why not? Those are two big buzzwords. We can always connect them together and make it even bigger. Okay, with that, I'll stop.
Thank you very much. So now we get into the QA session. So if you have a question, you raise your hand, and then a staff is going to send you a microphone. So while you're thinking about your question, I fire my first question to a panelist. So my question is, why has IoT come now? Is it because the electronic device, we have a better sensor, or because we have more connectivity, or both? Why today? We do not have SDN yet, as you could see, not much SDN, but still IoT getting bigger and bigger. We have this big event to host that. Not only that, many other places a similar kind of event. Why now? Why today?
Oh, me? So I guess there are a couple of things. I mean, they are all relatively straightforward. Wireless, the maturing of the wireless technologies, because as I mentioned, in Internet of Things, the things that are wireless and use very low power wireless, those are the interesting things, right? I mean, as you go forward. And those wireless protocols have only matured in last few years, right? And also the sensor technologies, because sensor technologies have a lot of analog parts to it. Whatever you want to sense, those sensor technologies and what is they call that, the reduction in size, all of that has happened in last several years. So that is why now it seems like a prime time. Those two things coming together.
Well, my comment would be down these lines. We're human beings. As human beings, we always want bigger, better, faster, more, and so on. And that's why this Internet of Things is expanding so much, because that's exactly what we're looking for as human beings, because we want it bigger, better, faster, and now.
I have 3 or 4 these things. So connecting is comfortable for me. That's maybe the human beings looking for everything to be connected. That's IoT now.
Okay, thank you. So any question on the floor? Anybody raise your hand? Okay, yeah.
Guru, could you give an example or two of what are the big hurdles that you're trying to solve in making SDN more widely useful beyond the data center?
Oh yeah, I mean, I guess trying to do a number of things. The first thing we're trying to do that I mentioned is building of this network operating system, the open source network operating system. So if you look at SDN, there are, in the simplest thing you can think of, there are 3 building blocks. At the lowest level, you have the forwarding elements. The next is what we call SDN control plane, that is built using something like a network operating system. And then on top of that, there are applications. So one of the things we are trying to do to make SDN more deployable and adaptable is to build a network operating system that is scalable, highly available and all of that, and make it open source so that the community can take it and run with it and build products and solutions based on that. And then we are also applying it to different use cases, as I mentioned, in the packet optical backbone as well as in the central offices and so on, and trying to demonstrate that this can be done. And again, do it in open source, and as a result, the community can build on it. And we're doing it with partners like Fujitsu, AT&T, and another half a dozen more companies. Did I answer your question, or you had something more specific?
That's fine, thanks.
Okay.
Hi, is there any relationship between OpenFlow and the work that you are doing?
Relationship between?
OpenFlow.
Okay. So OpenFlow is just a piece of the SDN, in the sense that OpenFlow protocol is what we define between the control plane and the forwarding devices. So that the control plane should be able to program the forwarding devices, and OpenFlow is the protocol that does that. And so we did a number of versions of that at Stanford, and then we created something called Open Networking Foundation, and that is continuing the specification of OpenFlow protocol with the help of, I think there's something like 120 companies that are part of it. But that is just one of the things that make up software-defined networking, the protocol between SDN and so on. The SDN is much bigger than that.
So I have another question. SDN, you mentioned the SDN and IoT right now, they have their own trends. They're not fully together yet. SDN, the part of it, the big part of SDN is about centralization. You know, you centralize the control. But in the world of IoT, you have many small devices. They only need very small amount of traffic. It may need the traffic probably very short period of time. That you have billions of those mice flow, they call it, or rather than elephant flow, mice flow. They come and go. So, but each connectivity require you open a new thread or some sort. They're going to put a lot of stress to your centralized system. This kind of stress is a little bit different from, you know, a big number of data. Instead of a big number of data, just in many connectivity requests from many places. So my question is, how do you envision SDN, this centralized system, can solve this kind of a problem?
Okay, so I guess first let me make an observation that when you have these small little devices, you have no choice but to have a central control. You cannot embed the control in every device like we do in routers and switches, right? Because if you were to run those distributed protocols that we run in routers and switches, there is no way we can run OSPF, BGP, and all those things in these very little devices. So we have no choice but to have some type of centralization. But your point is very valid in the sense that there are so many devices and they will have this very little small flows. So we have to come up with some ideas where, you know, as we talk even in standard SDN, the proactive way to set up the flow. So there is some state that is programmed that says all these devices. So first of all, these devices would hardly ever talk to each other directly. So in some sense, the flow is already set up to go from these devices to the gateway device, right? And so you don't have to do it every time they wake up. That particular state may exist for a while, and you program it only once in a while rather than every time there's a data to be sent, right? So for example, when you are standing on the weighing machine in Bob's example, only when you stand, you have to send the data to your Twitter saying you put on another 5 pounds, or whatever, right? So you have to do it only incrementally, and you don't have to set up a flow for it. It may be pre-set up.
Pre-set up, okay. All right. And a question from floor, yeah. Please.
This question is maybe directed to Min and Guru. I've been thinking about the security issue, and as you talked a little bit about SDN and IoT, is whether Min mentioned a little bit about VON, Virtual Optical Network. And as you virtualize that, I was wondering whether there's a kind of, like you can always do hardware encryption, which is fast, but it's not flexible. But as you virtualize, have VON, whether that can actually virtualize the encryption as well, and whether that can address some of the IoT security issues. I just thought your comments.
So yeah, I don't know in the context of IoT what virtualization would mean. So that is a difficult thing. I have not thought much about it, so I don't know what virtualization in IoT context would mean. In rest of the network, when we do virtualization, you can have all the data that is encrypted as long as your addresses are not encrypted. You can do virtualization very effectively, and it works just fine. Now, in the case of IoT, as long as your addresses are not encrypted, maybe the same idea would work, but I haven't thought about it honestly.
Yeah. So, yeah, also, sorry, I haven't thought about that much from that angle, because right now in the SDN, when we build in our controller, when we think about security, is about the security for the controller itself, most from that perspective. Not too much about, you know, the connected device, the security for the connected device. So it's not much into that area. But definitely, that's one big item that we need to study. Yeah, thank you. So we have less than 2 minutes. So I will go to the last questions. So it's a little bit more higher level. So and then ask each of you answer the question. Maybe use 1 or 2 sentences. What do you see our future network looks like 5 years from now, Bob?
Well, I'm going to go at a real high level. What I see the future network looking like, again, in my vision, because of we're going to have all of these Internet of Things out there, these devices, we're going to have these extremely fast, smart networks that are able to build up and tear down sessions extremely rapidly, but even more so securely. I know most of us talked about the security concerns and how important that is to the entire, not just SDN, not just IoT, but both of these technologies coming together and making sure that we can build not just a smarter, but also a more secure network so that we can handle these 30, 50 billion devices that are going to be on the network within the next couple of years.
Yes, I think I would like to say that two aspects. One is for the end user point of view, network will not be exist like a air everywhere. But that's one. Another point is ICT infrastructure point of view. We have to think about the energy issue. Too much such devices, total of the power is important. Right. So how to effectively manage at the network at the same time power network. That will be maybe one of the important topics.
Okay, so I guess maybe I'll divide the network again into two parts. I can't resist that, right? Yeah. So when you take the core part of the network, right, all the way up to the gateway leading up to the IoT, I think there I feel like in 5 years we will build more and more networks using white boxes that are built using merchant silicon. Maybe Fujitsu doesn't want to hear it, but you know that, right? You're part of it. So it will be built using number of network operating systems that are built around open source, and there will be acceleration of new services that people are able to bring to market, and that is where the value will be. So that is kind of the big network part. When we talk about Internet of Things, my guess is that in next 5 years, there will be more and more devices that will connect, but they will be a variant of kind of the smart devices, smartphones that we have. I think the vision of connecting those really small devices and so on, that will play out maybe beyond 5 years, not in 5 years, is again my pessimistic view maybe, but that is how I think.
Okay, thank you. So there's a closing statement. So IoT is happening, it's real, it's happening right now. So with IoT, we can do so many things that we cannot do before, so which will benefit our whole society. Connectivity obviously is one of the trigger points. We have IoT, with this mega trend today, but we have to make sure connectivity is not become the bottleneck when IoT in large scale. So that requires some maybe re-engineering of network. How do we, lots of open topic, lots of study point we need to study. But today we have this opportunity. Fujitsu Lab America organized this event. Thank you for that. And also especially thank our panelists and offer your insight, your perspective. We learned a lot from it. And last, we thank our audience coming here for this discussion. Sorry, we do not have too much time to have a more question, but thank you again.